Thank you very much, and good morning, everyone. I landed on this panel on automation, but actually my presentation is not really about automation. It's much more about how the overall air traffic management infrastructure should be organized, and it is definitely a topic that I believe should be addressed in this conference, and it seems this was the best location to anchor the presentation. The underlying idea behind this presentation is the observation that we have a comprehensive single open sky regulation in place, a full framework in place, but if we're honest with ourselves, we're still progressing at an unconvincingly slow pace. There's little concrete coming out of the implementation of the SAS, and the main reason for that, I think one of the executives of the Deutsche Flugsicherung said that a week ago in the best possible words. We are still looking at the issues of tomorrow with the thinking of yesterday. And what we're lacking is an agreed business model for the future or air navigation service provisioning in order to generate some sort of positive consolidation effects. We also observe that the functional airspace blocks are not yet delivering what we expect from them, and the progress is being slowed down by a number of governance and often self-invented institutional issues. A lot of the points I want to make in these presentations are already addressed in one way or another under the CESAR program, but the point now is what remains to be done is to bring all these elements together into a comprehensive and consistent business model. And what we have in mind is what we call the virtual center model. It echoes something we already heard yesterday in the presentation from Selex, but we take a slightly different angle to the concept. The virtual center is to be understood as a group of air traffic services unit, possibly managed by different service providers, that are operated on the basis of fully standardized equipment and procedures, so that from the airspace user's perspective, you have the feeling that it is a single system. You do not see that you have several operators behind the system. The airspace under the responsibility of the service providers is managed exactly as if it was the airspace of a single service provider. There are different ways to describe the air traffic management system, but for the purpose of this presentation, I'd like to highlight two elements. The first element is the controller's working position, meaning the display, the screens, microphone, and the tools that are available for the controller to do his or her job. And then there are all the systems and equipment downstream from the controller's position, and these are the systems that feed the controller position with the data needed to perform the work, be it the radar data, the flight data, environment, weather data, and so on. And presently, these ATM systems are monolithic and fully integrated systems. Each service provider develops or acquires its own custom-made system. This is a very costly process and also induce some sort of lock-in effect in the sense that if you want to change a little part of your system, you normally have to do that with your legacy supplier, or you have to change the entire equipment if you want to move to another equipment. So this business model, virtual center business model, I can show that with one slide. The principle here is to decouple the working position of the controllers from the data provisioning part. And in a nutshell, the service providers would focus on the working position and would acquire or could acquire the data from external suppliers. So there are three elements in this model. There is the Common Controller Cockpit, as we call them. There's what we call the information cloud, and in between you have a standardized interface that allows the service providers to plug in anywhere they want to acquire the data. The model is inspired by the development of aircraft cockpits and by the concept of cloud computing. If you look at the cockpit part of the equation, it's striking that if you go into, let's say, an Airbus aircraft, regardless of the airline you're looking at, there's a big degree of commonality from one Airbus cockpit to another, and it's the same with Boeing. They are aircraft families, which makes it quite easy for a pilot from one airline to move to the cockpit of another airline. And so the display, the human-machine interface looks more or less the same, although behind the cockpit there's a big variety of systems, totally different systems, different suppliers that feed the cockpit with the needed data, but there's also this common interface that allows the airlines to select what they want downstream from the cockpit. That does not happen in air traffic control. These air traffic management systems are highly customized to the needs of different service providers. And if we are honest with ourselves again, a lot of this customization is not imposed by imperative requirements, but much more by different ATM cultures. There is some sort of we've always done it that way culture, and also an element of not invented here syndrome that dictates how these systems are developed. So this common controller cockpit concept breaks away, first of all, from the integrated monolithic approach. It also assumes, and this is to be verified, that what is really of strategic relevance for the service provider is the common working position and not necessarily what feeds into the system. However, although I said that a lot of the customization is self-invented, there are some specificity at local or national levels that have to be recognized. For instance, you do not manage traffic in high-density airspace in the same way as you do in low-density. You don't provide air traffic control over mountains in the same way as you would do over flat Netherlands or over the high seas. There are different tools that are needed depending on your environment. And in this model, this would be reflected through plug-in applications that the service providers should be allowed or able to acquire on a market of specific tools. So this is for the working position part. Regarding the information cloud, the idea here is to make it possible for the service providers, instead of investing in a full data processing system, to be able to acquire the data from external suppliers. And this can be another service provider. It could be Skyguide getting data from, let's say, INAV, or it can also be from to be established data providers, commercial data providers that don't exist for the time, that could appear in the future. And that would mean that all the equipment downstream from the cockpit, the common positions, would be no longer form part of the equipment of all service providers. Then you can ask the question of what is the big deal? What would prevent today Skyguide from getting data from INAV? You could do that simply by putting working positions from INAV in the Skyguide facilities, but this is not the point. It has to happen in a much larger scale, because you don't want to be locked in with a supplier to be locked in with another supplier. You want to be able to change suppliers and also have multiple suppliers, and this is why you definitely need this standardized interface that makes sure that all the data is provided according to the same interface standards. Also, what's important with this model is that it's not a matter of developing technology. All the technology needed to put such a thing in place is already available, and the point here is simply to borrow technologies that are widely used in other industries and apply them to air navigation services. We see a number of benefits with this virtual center model. The first one for the service providers being that you reduce their dependency on a small number of technical suppliers. The second one is that you open the data processing and supply to competition. You're creating a market in respect of data. Individual service providers will no longer be compelled to buy a fully fledged system of their own, but they could share equipment and they could acquire service from competitive suppliers. And this would come, in our view, with the major benefits for the airspace users because it would significantly reduce the cost of investments. Another interesting thing with this model is that it does not require a big bang approach. It allows each service provider to progress at its own pace. There are some service providers that have just invested in classical integrated systems, and you don't want to impose them to move rapidly to another philosophy. So it allows all the service providers to gradually join this standardized approach. However, you should have a long or mid or long-term date where all the service providers should be aligned on the concept. The other thing is that it does not oblige all service providers to give up the fully integrated approach, but it allows those who do not want to follow that path to have alternatives. From an operational point of view, the virtual center as a whole, because you're standardizing both the equipment and the procedures, it also allows some economies in the sense that a service provider could be able to close its facilities in period of low traffic, let's say at night, and rely on services provided by another service provider. During the night, you saw the case yesterday, where you have controllers in the room to control 3 or 4 aircraft per hour. Is it worth the investment, or could we arrange different service providers working together and taking over traffic? It would also allow more dynamic allocation of air traffic sectors depending on where the availability of resources is at a given moment, ideally on a more or less live time scale. It would allow multiple service providers to pool their resources, possibly within functional airspace blocks, and it would also facilitate controllers' mobility. If you enter a fully standardized system, it would reduce the time that you need to retrain controllers to the real local specificity. Presently, it's 6 months to a year to move from one service provider to another, and the real amount of specificity can be significantly reduced, and possibly the training as well. And we believe that this virtual construction is also the option that would likely gain the support of the workforce, of the air traffic controllers, because it would induce a consolidation effect without forcing air traffic controllers to move from one service provider to another, from one location to the other. We all know all these beautiful projects of cooperation, they fall apart at the time controllers are forced to move from one place to another when they don't want to do so. And with this model, you can achieve the consolidation without having people to move, because you keep your facilities but just make them work together. So social acceptability is here one thing. Now, it's all beautiful. We mustn't be naive or deceived by the apparent simplicity of the model. We have to be aware that there are very complex risks and issues involved in this vision. For instance, you would be talking about dependency of service providers on data provided by third parties. We're talking about a sovereign function. How would states feel about the service providers getting its data for a foreign country? What happens if the supply is cut? There are issues of integrity of data that you have to make sure are addressed. Also, it's not that easy at all to move to train controllers for different sectors. Here there are issues of licensing that have to be addressed. But my religion as a lawyer is that I'm not that much interested in the problems. I'm more interested in the solutions. So I don't want to hear why the thing is not going to work. I'd like people to explain me how we are going to make it happen. And here this brings me to the conclusion. For such a model to be applied, you would need definitely a regulatory support to bring incentive for such a model to be implemented. And possibly here, the European Commission, and also under the CESAR program, there would be a need for some sort of regulation, taking the view that this regulation should be as light, concise, and simple as possible, and basically all that what that regulation should do is to set a time frame for such a model to be implemented, and then to define the specifications for the standardized interface that would allow this flexibility of plugging in. Also, probably there should be a reflection on European funding to support the early adopters of such a concept and to incentivize those who are willing to move to new ways of organizing air traffic control. So I just wanted to throw these ideas to you because I think it's worth a reflection, and this is something that can only evolve with contributions from the entire industry. Thank you very much.
Thank you very much.